Today I'll be talking about quantitative methods, and the focus will be on correlation and linear regression analysis. What is correlation? Correlation refers to the degree of joint variation that exists between two or more variables, while linear regression analysis is a statistical technique that is used to study the relationship between variables. There are two types of linear regression, and they are simple linear regression and multiple linear regression. Simple linear regression is used to study the relationship between only two variables, while multiple linear regression is used to study the relationship between several number of variables. Linear regression works with numerical values only. But if you have to include qualitative variables in your study, you have to convert them to dummy variables, and dummy variables take the form of 0 or 1. Types of correlation. There are 3 types of correlation, and there are ways by which you can identify the type of correlation between your variables. You can use Pearson correlation coefficients. In statistical terms, the correlation coefficient, which is also called Pearson correlation coefficient, is denoted by R. It expresses both the strength and direction of a relationship between two variables by using a single number. Another way by which you can identify the type of correlation between your variables is to plot a graph, and that graph is called a scatter plot graph. When you've plotted your graph, you need to observe the direction of the line. That line is called the line of best fit. If the line moves from lower left to upper right, it tells you that the correlation between your variables is a positive linear correlation. You also have to observe the pattern of the dots on your graph. If the dots are closely clustered around the line, it tells you that there is a strong positive linear correlation. If your scatter plot graph shows a line that is moving from upper left to lower right, it tells you that the correlation is a negative linear correlation. And if the dots are closely clustered around the line, it tells you that there is a strong negative linear correlation. If the graph shows you a horizontal line, it shows you that there is no linear correlation between your variables. On the other hand, if your positive linear correlation graph shows you that the dots are very far away or they are scattered around the line, they are well dispersed, it shows you that there is a weak to medium positive correlation in the case of positive linear correlation line. If the dots are far away from your negative linear correlation line, it shows you that there is a weak to medium negative correlation. Lastly, if your graph shows you a curve instead of a line, it tells you outrightly that there is no linear correlation whatsoever between your variables. Please note that correlation does not imply causation. What are the examples of positive, negative, or zero correlation? I'm going to be talking about examples to explain better what positive, negative, or zero correlation really means. A good example of a perfect positive correlation can be seen in the relationship between heat and temperature. When you apply heat to a metal or any object, you will notice that the temperature will begin to rise. The more heat you apply to the object, the higher the temperature will rise. But when you begin to reduce the amount of heat that you are applying to the object or the metal, the temperature will begin to reduce. This tells you that the value of heat and temperature are moving in the same direction. That is a good example of a positive correlation. On the other hand, the relationship between income and poverty has a negative correlation. When you earn more income, the level of poverty that you're likely to experience as an individual will begin to reduce. But when your income starts to reduce, the level of poverty that you're likely to experience will begin to increase. That shows that the value of income and poverty are moving in opposite direction. That tells you that there is a negative correlation between income and poverty. Lastly, when there is no association between two variables, it tells you that there is zero correlation. A good example of this can be seen between your height and your IQ. Your height in any way does not tell us how intelligent you are, because there is no correlation at all between your height and how intelligent you are. This symbol R is the Pearson correlation coefficient, and this is the formula for R. N is the number of samples. X bar is the mean of your X variable. Y bar is the mean of your Y variable. S here and S here stands for standard deviation for X here and for Y here. Your R takes the value of -1 to 1. When R is above 0, that is when R is larger than 0, it tells you that there is a positive relationship between your variables. The closer R is to 1, the stronger the relationship. When R is less than 0, it tells you that there is a negative relationship between your variables. The closer R is to -1, the stronger the relationship. When R is equal to 0, it tells you that there is no relationship between your variables. How can you tell how weak or how strong the correlation between your variable is? By using R. You need to study this part for the benchmarks which are used for establishing the level of correlation between variables. You can pause the video to take a good look. In order for you to carry out a correlation analysis, the relationship between your independent and dependent variable must be linear. As I already told you, when your graph shows you a curve, it tells you that there is no linear correlation between your variables. There are other types of correlation measure, and they are Spearman's rank correlation coefficient and Kendall-Rao correlation coefficient. But Pearson correlation coefficient is the most commonly used, is the most popular, and is my favorite. What are the functions of correlation and linear regression? Correlation is used for finding the characteristics of psychological and educational tests, such as reliability, validity, and so on. Correlation is also used for testing hypotheses. It is used for predicting what the value of a variable will be based on the knowledge of the value of another variable. Linear regression is used for projecting the values of variables in the future. In other words, it is used for forecasting for the purpose of control or policy purposes. Let's talk about simple linear regression by solving a problem or by doing an exercise. How do you carry out simple linear regression analysis? First, you need to have a theory or a hypothesis. Then you need to specify the econometric model for the hypothesis. Then you need to gather data or you need to obtain data. Then you estimate the parameters of that model. I'm going to be talking about that as we continue. Then the fifth step is to carry out hypothesis testing. When you've done all that, then you can do your forecasting. And lastly, you can use the model for control or policy measures because that is the main objective. Now, let us state a theory. Kenney's theory tells us that when there is a change in, or when there is an increase in income, it will cause the rate at which people spend to increase more than before, but that increase is only greater than 0 but less than 1. Let me say it the way Kenney stated it. Kenney postulated that the rate of change of consumption as a result of a unit change in income is greater than 0 but less than 1. Now, this is the model, the econometric model for that theory. Y, as you see here, is dependent variable. Beta 1 is the intercept or the constant. That is the value that y will take when x is 0. That is the intercept. Beta 2 is the parameter, which will later become an estimate when we've carried out the analysis. X is independent or explanatory variable. This Greek symbol here is the error term. The next step is to obtain data for the analysis, data of the variables. And remember that we are talking about consumption, expenditure, and income. This data is the personal expenditure of the people living in USA in 1982 to 1996. And it's also the data for gross domestic products of USA in 1982 to 1996. Please note that the values are in billion dollars. Now, Y is personal expenditure and X is GDP. Personal expenditure will represent consumption expenditure and gross domestic products will represent disposable income. A graph was plotted between these two variables, that is, personal expenditure and gross domestic products, and you can see that the line is moving from lower left to upper right, and the delta are closely clustered around the line. This tells you that there is a strong positive correlation between personal expenditure and gross domestic products. The next thing to do is to use SPSS to carry out the linear regression analysis. You have to import the data into SPSS, or you have to type the data into SPSS, but it's better to import your data. The next thing is to click on Analyze, then click on Regression, then Linear. When you've clicked on these important features, this box will pop up. Then you insert your dependent variable in the upper box, that in this case is personal expenditure. Then GDP is the